right, cool. So thank you everyone for joining this session, and thanks Mark for the opportunity and also hosting this session. Really appreciated that. And we are going to talk about direct lake feature of Power BI, which is working usually when we have Fabric set up, and we'll talk about that shortly. But before that, about me, I'm Reza Rad, Microsoft Data Platform MVP for some years and Regional Director. I have written some books on Power BI, which some of them are free. You can download from RADACAD websites. The rest you can actually get it from Amazon or other sources like that. I write blogs quite often and also do or publish videos on YouTube as well on Microsoft Power BI and Fabric. So if you follow RADACAD website and YouTube channel, you'll get the updates about some of those. So that's about me. Let's jump into the topic. Now, before talking about direct lake, I thought we'll do a very quick introduction on Fabric first. And during the presentation, anytime you have a question, just feel free to put it in the chat window. We'll get to those questions at some point. So what is Microsoft Fabric? Microsoft Fabric basically is an umbrella on top of three main data-related products of Microsoft: Power BI, Synapse, Azure Synapse, and also Azure Data Factory. What happened is that Microsoft team thought that to build a data analytics project, Power BI itself is not enough. Yeah, and it never is. Like when you build a solution with Power BI, you combine it with a lot of other things. You combine it with a database place to store your data. You would have a separate ETL process sometimes, such as Azure Data Factory, Informatica, things like that, to bring data somewhere. And then you might combine some data science operations on top of it. So you would go and use a combination of technologies. The idea of Fabric is to give you all of those technologies that you would need in one environment, in one cloud-based environment, and that is why we call this experience SaaSified experience. So it is a cloud-based environment that get you all the components you would need for a data analytics project, from connecting to the data, transforming it, doing the ETL, to the storage layer, having the database to store the data, doing some data engineering practices, such as using Notebook, machine learning aspects of it, using data science, Python on top of it, doing some real-time, visualizing data in Power BI, and all of that. And it is not only including those, which we call them workload, each of these aspects. It also includes a one storage layer across all of these, that all of these components or workloads or modules would be able to use that storage layer to work with the data, called one lake. And the idea is that you would need one instance of your data entity across one lake. You don't need to duplicate it, and using features such as shortcut, which I'm going to talk about a little bit later in this session, that is possible. Now, all of these components can be governed throughout the Fabric portal experience, but it can be also enhanced using Purview, and the AI agents such as Copilot also exist in some of these aspects, which can help building the solutions, such as Copilot in Power BI, Copilot in Data Science Experience in the Notebook, Copilot in Data Factory, Dataflow, and things like that. So that is like a very quick overview of all of these. Now, my sessions usually include quite a lot of demos, so I'll jump right into a demo just to show you one quick view of this. So here I have my Power BI environment. So this is, let's say, the workspace that I have, which I want to build some of the components in it. Now, when you have Fabric enabled, you would have this option that you can go and choose different workloads. Power BI is just one of those workloads, but you have plenty of other things to use. Now, I'm switching to data engineering experience here. The data engineering experience would give me ability to use an object we call Lakehouse. Lakehouse is basically something like a database or data warehouse, let's call it, but with the fact that it also enables you to store files in addition to the tables. And those are like even non-structured data files, such as image file, PDF file, things like that. So I'll create a Lakehouse. Let's call this Lakehouse San Francisco Adventure Works Lakehouse. The Lakehouse itself would spin up a Synapse data warehouse behind the scene, but it's a second generation of Synapse data warehouse. We don't call it Synapse warehouse anymore. We would call it basically a Lakehouse or a warehouse in Fabric environment. This is what you see at the moment is what we call a Lakehouse Explorer. This is the place that we would see the tables and files we have in here. At the moment, I don't have anything loaded into here. So what I'm going to do is to just load some data into here. There are different ways that I can get data loaded into this environment. Pipeline is one of those. Dataflow Gen 2 is another. I'm going to start with a new Dataflow Gen 2. Dataflow Gen 2, for those of you familiar with Power BI, is similar to Power BI data flows with one big difference that it has a destination. The data that I build through that Dataflow Gen 2 can be then loaded into a Lakehouse or a warehouse or any of those destinations. 4 destinations are available using this. So this is my Dataflow editor experience. I'm going to get data from Excel, and this is my Excel file, which I'm using as a sample input here. Clicking on next, this is the AdventureWorks sample data. Which is an Excel file, and it has multiple sheets in it. Each sheet basically represents a table. And now here I have those tables. I'm going to select, for example, customer table, let's say product table, product category, subcategory, and fact internet sales. So I'll select a few of these tables. And then when I create that connection, it will load that into this experience, which is the online Power Query editor. For some of you already familiar with Power BI, this is similar to that Power Query editor experience we have inside Power BI desktop. It has some enhancement as well. Like here, we would have that that diagram view, which can help to see some of these elements much easier and much better. So for example, if I want to combine some of these tables, let's say I want to merge the product table and product subcategory, I can use this diagram view actually directly and say product, merge query as new, and then I merge it with product subcategory using product subcategory key here and product subcategory key there. I can go and choose the merge type. In this case, I'm going to keep it like that. Click OK. This would merge the 2 tables together, and it would show me also a nice diagram view of how these 2 are merged together. It always shows me a preview of data down here. The preview of data here is always like 100 rows, but it can become more if you scroll down to get more rows. Now, let's say in this case, I'm only interested in this column, which is name, and this result of merge. And then I right click and say remove other columns. As I do these transformations, you see that these steps of transformations get added into the query setting, plus they also get added here. Like for example, here I would expand to product subcategory name and product category key, and that would also add another step. If you ever want to like go back to the previous step to see what the data look like, you can basically just click here and look at that data. This is the similar experience of Power Query in Power BI desktop. One last step here is that I would then just merge this back to the dim product category table using product category key here, product category key there. I'll use the left outer join as the default outer join. So this is the 3rd table I'm merging. I'm basically flattening these 3 tables together, then expanding it, selecting product category name, which is giving me my full table here. Then I don't need category key anymore. I'll remove that. You see a lot of null values here. The reason is that we have like not every product has a category or subcategory, but if I scroll down well enough, you see that there are some category and subcategory information. So this way I can do whatever transformations I want, and there are much more transformations available in the Transform tab. After I do my transformation, I can name this table as a product table. I wouldn't need the product category or subcategory or the product or the dim product anymore. I can basically right click on those and disable them from the staging. In this case, because the output of this is going to be a lakehouse. And that is another thing about this data flow Gen 2 is that you get this data destination, which is where my mouse is. It shows that automatically it set the destination to the lakehouse that I just created. The reason is that I created that data flow experience from that lakehouse experience. If I just create the data flow separately, then I could go to add data destination and choose that destination, whatever I want. In this case, it automatically maps it to that lakehouse. What I do want, however, is that I don't want the dim product to be loaded in my lakehouse. So I'll go and remove that destination, because that is these three tables, dim product category, and dim product subcategory. They are used to create that product table at the end. So I'll basically just go and disable the load of those three using this option. So they would not have a destination. As you see, these three don't have a destination, but the others have destination, like the customer table, like the product table, and each of these I can click on. So we have done the transformations here, selected all the, let's say, selected all the tables, the transformation related to that. And then the data flow Gen 2, which is the type that we are using at the moment, usually store the data as a destination. In this case, the destination is the lakehouse because it is using, because I started creating the data flow from the lakehouse, so that automatically mapped the destination to be that lakehouse. If I started data flow just by itself, then I had the option to say add destination. Then I would have the option to choose a lakehouse, warehouse, KQL database, or Azure SQL database. So in this case, I'm going to use that. And for dim product category, and subcategory, because those three are used to create the product table, I don't want them to be loaded in my destination. So for those, I went and removed them from the destination. But for the other tables, such as product, fact, sales, and dim customer, I can go to this setting. This is the place that I can set up the mapping with the destination lakehouse. If it is not already there, I can create it. If it is already there, I can just go and confirm everything is all right. In this case, because I don't have a table over there, it is going to create that table. So I'll go ahead and just check the mapping, all looking fine, save settings, and this would create that output. Same for the other tables, but I don't need to go through that process because it is automatically set already. I'm going to call this data flow adventure works, and then publish it. So what is going to happen right now is that the publish process will save that metadata, the process of creating the tables, the output tables with their structure. Then it will run through that process of getting data from that Excel file. But this time, not a preview of data. This time, the entire data, whatever it is available over there. And then we'll load it into that lakehouse. So the tables will be created in the lakehouse, and they would have some data records in them. This would take a little bit of time, but while this is running, I'll just go to the lakehouse and see if this is getting anywhere close to loading. It would take some time, so I don't expect this to run real fast. But while this is running, any questions so far?
Looks like Gonzalo had a question, just talking about the splitting outputs to destinations. So, multiple queries set up for different destinations.
You can have each query to have a different destination. That is right. But the way that you usually would do it is that you wouldn't go and create it from the Lakehouse experience itself. You would go and create a new data flow Gen 2 from here. And then for each of those, you would set up a different destination. So it is possible that one data flow push part of the data into a warehouse, another part to a Lakehouse, to a different workspace, and all of that. Okay, now I think the tables should be loaded and having some records in it. Yeah, here it is. So I have my three tables. As you see, only product tables got loaded and not dim product category, dim product subcategory. And when I click on any of these tables, I would see the actual records in those tables. This experience, as you see it, this is basically what we call as the Lakehouse Explorer experience, where you see the tables. If we have files, we would see also the files. you can then switch from the Lakehouse experience to SQL Analytics endpoint. SQL Analytics endpoint is where we actually go and see this as a database, basically. So here we would have the tables, all of them at the moment created under DBO as a schema, but you could create different schema, one schema for dimensions, one for fact tables, one for a schema, for example, for sales, things like that. You can separate these if you want. In here, not only you can see the tables, but you can also go and query this and write a SQL code in here. For example, things such as select top 10 star from product. Like a normal SQL database or a data warehouse, you can basically run your queries. You can save this query as a view if you want. And you can write, of course, more complex queries. The queries that you create, you can write them using the SQL code like this, or you can create what we call a visual query. Visual query would give you like a Power Query experience where you go and build these queries using the UI by just dragging and dropping these elements and building that. Both of these, after you do your transformation, you can save them as a view, as a SQL view, and it would be added as a view into your database. This database can be also connected using what we call a SQL connection string. I can use that SQL connection string, and I can use something like a SQL Server Management Studio to connect to that if I want to, and then write SQL scripts and things like that from there too. The Lakehouse or warehouse, if we create warehouse, would be the same experience as well, always comes with this model tab. The model tab is where we actually have the default data model of Power BI generated for it. So all the lakehouses or warehouse, they are always coming with what we call as a default semantic model. The default semantic model has the tables that we already have in our model. In this case, customer table, the sales table, plus product table, but you also see that there are other tables in here, tables that I have not created. These are DMVs, dynamic management views. These are some queries that can, some views that can help me to monitor the performance of my lakehouse or warehouse, like how many queries are running at the moment, what was the longest running query, things like that. If you want to analyze those, you have them, you can build them inside your Power BI solution and start building something like that. This experience here also gives you ability to go and build your data model. So I don't really need to go to Power BI Desktop to build that. I can easily here go and create a relationship based on product key between these two. And it would give me ability to set up the relationship exactly the way that I wanted. For example, between customer key over here and customer key over there. So I can go and actually build whatever I want, not only the relationships. I can also go and, for example, select a column and say, I want to hide this column. Or, for example, you can go and select a column and say you want to format this column, in this case, sales amount. I want this to be a currency format, let's say, with 0 decimal places, things like that. So it gives you a good model editor experience online. You can even create measures as well out of this. But you cannot create calculated columns, you cannot create calculated tables. There are some limitations in this, but it is usually good enough to go and create a new report from it. This is called a Power BI default semantic model on top of a lakehouse or warehouse. When I hover on top of these tables, you see this blue stripe here. That is basically showing that this type of connection that we have from the Power BI semantic model to that table is called direct lake. And you see that direct lake basically showing in that description. And that is what I'm going to talk about in a second, very shortly. But before that, I would like to first explain a little bit about the difference between lakehouse and warehouse, and then we'll jump into that. So let's go back to the slides. This might be sometimes confusing because we have multiple objects inside Fabric environment. We have the Lakehouse, we have Warehouse, and previously we had Power BI Data Mart. These three are kind of very similar to each other. You might wonder what is their differences. So in in this view, they are all the same. You would always have an ETL process that gets data from the source, does some data transformation. Usually that's data flow Gen 1 or Gen 2, depending on which of these objects you go and use. They would load data into these storage options. So these are more like a database, each of these. Then you would have a Power BI dataset or semantic model on top of it, and then Power BI reports connected live to the semantic model. So in this kind of architecture, they are all the same, but there are differences. For example, data mart is the only option that you can create if you have licenses such as PPU, premium per user. But if you have fabric capacity, you can create all of these. Like you can create a warehouse, lakehouse, and data mart. But with PPU, data mart is your only option. So license is one difference. Another difference is scalability. With the Lakehouse and Warehouse, you have the back end of Spark engine that allows multi-parallel processing engine and things like that. So it is much more scalable engine compared to the Azure SQL database that Data Mart is based on. Lakehouse is the only object that also gives you ability to store files in addition to the tables. And those files can be PDF files, image files, things like that. The SQL endpoint is another difference. The SQL endpoint of Power BI Data Mart is really limited. You can still query the data, so that is good. The SQL endpoint of the Lakehouse is also enables you to query the data, but there's a little bit difference. It is much more, let's say, it is more flexible compared to what we have with the data mart. With the data mart, you don't even see the tables. You see views and you work with the views, whereas with the Lakehouse, you have the tables, but you can only do read-only queries through SQL endpoint. And then data warehouse, on the other hand side, give you a full SQL experience, but it wouldn't give you the ability to store files. So pros and cons. Each of these has different situation. One of the main differentiator between these is looking at what type of user you are. If you consider yourself to be a citizen data analyst, someone who doesn't have much experience in databases, Data Mart is a great choice because without knowing how to create a database and things like that, it creates that for you. You can go and use it. Whereas someone who is more like a data engineer would use a notebook, Python scripts, R, SQL, things like that. Lakehouse would create much better experience. You would also have ability to work with the files through your data science experience, things like that, using some of the Python libraries. And finally, the warehouse would be much more comprehensive option for a database developer, someone who basically works through a SQL code, most of the things, writing data as well as reading that data. Another big difference is, of course, the direct lake, which I'm going to talk about it separately. So for now, let's skip that part. So all-in-one comparison, it's something like this: data warehouse versus Lakehouse versus data mart. They are all kind of storage options, but Lakehouse and Warehouse are more scalable. Lakehouse gives you ability to store files as well, but limited SQL experience. It would be more like a read-only SQL scripting through the SQL endpoint, whereas Warehouse would be full SQL read and write experience. With the Fabric capacity licensing, you can basically create all of these. Now, with the Lakehouse and Warehouse, which are the objects we usually use when we do the direct lake process, there are a couple of interesting features. One of them is mirroring, which is quite helpful when you have your data elsewhere and you want to bring that data into your Fabric environment. Let's say you have your data in a Snowflake, and usual process is that you go and integrate that data, bring it here, such as, for example, data transformations, doing a lot of the pipeline and data flow to bring that data inside your Fabric environment, and build a warehouse that brings that data. This process takes quite a lot of time. And you don't do it like one-off thing. You have to write your process in a way that it keeps it always synchronized, so that when the next time Snowflake data changes, tomorrow's refresh would bring those changes. Mirroring basically does all of these for you without you doing it, right? So it's much simpler process. It basically creates a replica of that source. In this case, let's say a Snowflake. It creates a warehouse inside Fabric environment that we can have on top of it a semantic model and Power BI reports or paginated reports. This warehouse would be an exact replica of your Snowflake source. And you don't need to worry about synchronizing these two. It would automatically synchronize it. It is a great option to reduce the cost on the source system, such as a Snowflake, as well as giving the ability to do any reporting you want inside Fabric and Power BI, because when the data is available here, you can do let's say queries cross data warehouses and things like that. So that's mirroring. The next one is Shortcut. Shortcut is giving us ability to connect data across OneLake. So OneLake is this big storage that we have all the data in it. And in OneLake, we can have our data like organized within domains, which is the concept of data mesh and things like that. Inside domains, we can have workspaces. Inside workspaces, we can have objects such as Lakehouse, warehouse, things like that. It is quite often a requirement that you need a table from another object, such as a lakehouse or warehouse, to be added inside this object. For example, you are building a lakehouse or a warehouse for sales, and you need a date table, and that date table exists in another lakehouse. You can create a shortcut to that, basically meaning that you would not copy that data. Shortcut is also called one copy. You do not copy that data. You would use that single copy of the data wherever it is. You just point to that, but it would be considered as a table inside your environment without creating a new copy of that, right? Which is a fantastic feature, because this means that you can reuse your objects instead of creating that. Now I'll show you that bit a little bit, and then we'll go to see if there's any questions. So here, this lakehouse that I've created, it has customer table, fact table, product table, but it doesn't have a date table. If I want to bring a date table in this experience, I can actually go and create a shortcut to another lakehouse. So this is how we go and create a new shortcut. Here I would say go and create a new shortcut. Shortcuts can be external to sources such as Google Cloud Storage, Dataverse, Amazon S3, but it can be also across my Fabric environment. So I'll go and select that. And then I have here, let's say one of these, which I'm going to use, this Lakehouse General, for example. It is another Lakehouse, but this one has a date table in it, which I'm going to use that. So this date table, I'll just select it, and then what happens is that this will create a link to that table. It will not copy the data. The data is still part of that lakehouse. But this table, as you see, it is created and it has one little link icon compared to the other tables, but it is like a table like any other tables in my model. So if I go, for example, to date table, I would see the data of that date table easily available here. I can switch to my SQL Analytics endpoint. In there, this would basically look like a normal table. You see, even that link icon is not there. So these are all looking like a normal table. I can go and create a query join between one of my tables here and that table. All of those would work fine. This would be like a normal table that I can use to do anything with it. And there wouldn't be any limitations on that, not only in the query side, but also in the model side. My semantic data model, Power BI model, can now have that date table, which then I go and connect it to my sales table, let's say using something such as order date key to something like, well, I don't have date keys, so I'll just connect the date, order date to date, right? So this would be like a table inside my model, exactly like that. It should be the other way around, but you got the point how this works. So from my semantic model point of view, this is a table like it exists in this lakehouse. However, the actual table exists elsewhere in another lakehouse. And this ability to reuse those objects is one of the most interesting things we can go ahead and use. Any questions so far?
So there's a comment from Deva that maybe you can just describe the pros and cons for. Deva says, no need to create calculated columns as you can create the column in SQL itself, and maybe you could comment on one approach versus the other.
Yeah, calculated columns, if you can create it down in the database or you can create it using data flows, that would be preferred, of course. So most of the cases, most of your DAX calculated columns can be done over there. Usually those are preferred because then you can use it in other places. However, there are some certain scenarios that still creating calculated columns in DAX is more beneficial, but they are not really a lot of use cases. One of those is when we want to parse a hierarchical structure. Path functions in DAX give us a really good way of doing it, whereas in SQL you have to write that as a CTE or something like that, or in data flows, you have to create a recursive process. So general rule of thumb, I would create calculated columns back in the data warehouse or using data flows, unless it proves to be more complicated than a normal scenario.
Yeah, I think that's what David had in mind in the original comment. And then Barsham is asking, how much of a performance hit do we get when creating and using a link?
This would be like a normal database. So when we create a normal database table, so when we create that shortcut, a shortcut to this date table would be working exactly as my product table. In this case, because they both are from OneLake. But if you create a shortcut from your like external links, Google Cloud Storage and things like that, then it would be dependent on how they perform. However, with the shortcuts, we don't have a copy of data, but a caching happens. So the first time it might be a bit slower, but then after that, it becomes a bit faster, things like that.
Okay, thank you. And then those are the only questions that have been posted, but if anybody during this quick break for questions, if anybody else wants to ask anything, you can come off mute briefly if you'd like to ask Reza directly. Otherwise, we'll
I think we can continue and then stop on the next point. Okay, now thank you, Mark. So the next thing about this structure in Fabric is that something we call Delta Lake. Delta Lake is a format or is a standard, open standard format of storing the data of a table. This is not for Microsoft. This is used basically across Apache Spark or Linux. Other technologies have leveraged the same thing, like Databricks is using the same format of storing the data tables. It comes with some benefits. For example, it gives you ability to work with the data like a normal database, like you can update, insert, delete through a transactional process. You get something really interesting called time travel, which basically means that if you want to see the data as, let's say, 3 days ago, you can do that, even if the data got updated. You get some auditing, things like that. So it's quite a beneficial thing. The way that data is stored using this Delta Lake structure is something like this. So we have the table itself as a folder. Under that, we would have a bunch of Parquet files and a folder for logs. Under those, we would have a bunch of JSON files. Parquet files would store the actual data. So the data will be stored over there. With the changes, it might create more Parquet files. The JSON files would have pointers to which Parquet file is good to use for which point of the time. So a combination of these two would give us a good information of what table, what data is available at what point of the time. And the Parquet file itself is a columnar stored structure for storing the data. This is also an open standard format. So if you compare, for example, Parquet with something like CSV, CSV is more human readable. Parquet is not that much human readable, although there are Parquet viewers you can install and see that if you want. Parquet is stored in columnar store format, so it is stored much more efficiently. If you compare a CSV file with Parquet file would be much smaller in the size, but it also would be much better performant when you query the data. So Parquet is definitely better option compared to something like CSV. And that is what is used in the Delta table structure. Now, the reason that I'm explaining this is that it is related to what we call as direct lake. So let me go to that direct lake aspect of this, because that is the main part I want to talk about in this talk. So in Power BI, we have different types of connections. We have import data, we have direct query, live connection, composite model, and direct lake. In order to understand direct lake, let's talk about import data and direct query first. Import data is saying that the data will be imported into Power BI from whatever source you use. So what happens when you connect to an Excel file or when you get data from SQL Server, when you use import, Power BI will basically create a copy of that data into Power BI engine. You might call it Analysis Services Tabular Engine. You might call it Vertipack Engine. You might call it Power BI Engine. Doesn't matter. It has many names. That engine will actually store that data into files, into its own proprietary file format. That proprietary file format, it's a column store format, which then makes sure that whenever you query that data, it would be really fast. That is one of the reasons that import data is super fast. You would have no limitations in terms of using Power Query, DAX, anything like that. It is a good performance. The only problem with import data is that you have to refresh your semantic model in order to get up-to-date data. The other thing is direct query. Direct query is usually the option we use for a huge data set, something that the refresh of that would probably take ages. So instead of doing like import data, we would keep data as direct query, which basically means that data remains in the source. Power BI would just generate a query, send it to the source, such as SQL Server, the result comes back. So when you look at, let's say, a Power BI visualization, it will create behind the scene a SQL code, SQL script, SQL query, will send it to the SQL database, the result comes back. If you look at one Power BI report, you probably have 4 or 5 of those visuals. So 4 or 5 queries will be sent to the source, the result comes back, which can be really slow. So direct query is slow, but the other hand side, it's always live data. So whenever you see that number, that is the number as of now. Now, with direct lake, it's a breakthrough actually type of connection. The way that it works is that if you think about that import data, I told you that Power BI would create a copy of that data from the source, store it in a column store format in its own proprietary file format. Now, the Delta Lake structure that I just talked about with you, that Parquet file in Delta Lake, that is column stored format. Right. So Power BI then just go and read data from that Parquet file directly. Basically, that is the thing that is different here. So Power BI will read directly from the file that contains the data of that table. That file happening to be Parquet file. So Power BI doesn't create another file for itself. It considered that Parquet file as its own proprietary file format. So Power BI basically is acting like import data. Whereas the situation here is that it is actually looking at the data itself. So if the data gets updated, Power BI has the new data. So it is kind of direct query, acting like a direct query, and it is also kind of acting like import data, which is quite interesting. So that is the new type of connection, which is available when you only create a lakehouse or a warehouse, because they both create that Delta Lake format structure with the Parquet file. So that is how it does it. So let me go and show this to you. So back into my framework. So here I have this structure of the tables and things like that. Now what I'm going to do is I'm going to actually create a new semantic model on top of it instead of using the existing semantic model. So I'll go ahead and create a new semantic model. When you create a new semantic model, you have usually more capabilities. The new semantic model will load the enhanced UI or enhanced model editor experience, which is different from the default semantic model. That is what I usually recommend people to go and use the new semantic model, the custom semantic model rather than the default semantic model. But the direct lake is available in both of these anyway. So when I create it like this would bring those tables into my model. It is only supporting the tables, of course, not the views. But then it would load the model editor experience, which is this. So this is like a normal model editor experience that you have inside Power BI. Then I'll create connection, let's say based on product key to product key, if I can find it. Product key, here it is. Yep, product key to product key. Let's say customer key to customer key. The difference here is that this editor would give you much a better experience as well, because you see here I can also create a calculated table. I can create calculation groups. I can create row level security setup, things like that, which I couldn't be able to do that inside the default semantic model experience. Anyway, I just wanted to show you this. Now I'm going to create a new report out of this. Let's say this report is a really simple report, just showing the sum of sales. In this case, I'll bring sales amount as a card visual right over here in my report. So it is $29 million sales. Let's say this is it, right? Then I'll go to the report and I set the report to be on an automatic page refresh of every 1 second. In case the data behind this changes, I want this to show me immediately that the data has changed. I'm going to save that report in here, calling it report 1. It's fine. Okay, so I have this report 1, which is basically showing me $29 million sales as of now. Now, what I'm going to do is that I'm going to my Lakehouse. Then I'll go and update some records in my Lakehouse. One of the ways that I can update is, of course, loading more data into that. Another way is that I can create a notebook. And then in the notebook, you can use SQL command to update it. So that comment about SQL command has to be read-only is only from the SQL endpoint. If I use the notebook, I can also do the update as well. So this is my notebook now connected to this Lakehouse. And I have these. Now I'm going to change this to be a SQL code. And what I'll do is update fact internet sales, set sales amount to be equal to 1,000. So basically this means that every single sales amount value in every single row is going to be this number. So if this completes, that number that we have in the report should increase significantly. So I'll wait for this to run. The report, as you see, still is $29 million. But once this is completed, and I'm running this on a trial capacity, so it's not really running that fast. But considering that direct lake experience I mentioned to you, it is the import data experience, but as soon as the data also gets updated, this should show me the change. It would take a little bit of time, of course, but it would happen quite in a reasonable time frame. So it is completed. If I go to my report, the next refresh, which would happen anytime, should have this change in it. So here it is. You see, it's not instant, but we see the change in a very reasonable time frame. And that is because of that direct lake experience, that Power BI basically reads data from that Parquet file. As soon as something changes, we get that updated in our report immediately. Do we have any questions for now?
Yeah, so we've got a couple that have been posted. I also see some applause there. So David's got a question related to when to choose Data Mart versus Lakehouse versus Warehouse, and maybe you want to cover that at the end instead.
Yeah, we already talked about that. So if you watch this recording, maybe you joined a little bit later. If you watch this recording again, I already mentioned the differences.
Yeah, it's you mentioned the differences. I think he's looking for specific scenarios, but you've got the chart on that you posted.
Yes. Yeah.
As well. And then Dylan is asking, can you handle row and object level security in a more logical, organic way with a combination of partitioning the Parquet files and using the shortcut feature of the Lakehouse? In other words, a bunch of connected warehouses that are tailored per business unit.
You can do that, of course. Yes, you can do that. You can create like a bunch of different lake houses or warehouses, each supporting different kind of business unit. That is actually what we call as a concept of data mesh. And then they borrow tables from each other. Like, for example, your marketing table would borrow the sales table from the sales, let's say, warehouse or things like that. And it would act like a table inside that warehouse or a lake house. And then you would have the direct lake experience on top of it. So yeah, the short answer, absolutely possible. And it is a good way to do that. You just need to make sure that you have the right culture in your organization so that different parts of the business would take ownership of these different data warehouses or lake houses. Or if you want all of these to be under the ownership of the IT team or the BI analytics team, that is a different story. Can be possible, but then you might get to the point that why not creating all of these under one when the ownership is one. So a bit of both cultural, let's say, requirements, setup, and also the possibility. It is possible, but would you do it or not, depending on the requirement.
Okay, thank you. And then Dylan's also asking, how expensive is the consumption of Direct Lake? Is there a better way to monitor it than the tool Microsoft provides, the Fabric Capacity Metrics app?
Yeah, so let me explain about that. That's a good timing for that question, which brings us to some of the discussion after that. So thank you, Mark, again. So with the Direct Lake, there are a couple of things that you need to consider. First is that I mentioned that Direct Lake doesn't really need the refresh of the data. But when you go to a semantic model that you have created, you would see that refresh option. So if I go to, for example, this semantic model, under the setting of the semantic model, there is a refresh option here. So what this refresh basically means. So that delta table structure that I mentioned, delta lake table structure, basically means that it would create new Parquet file as changes comes, and the JSON log files would point to these new files. This when you have this option enabled, Power BI would know that like whenever a new file is created, it goes and look at that file, which is a good thing. That actually enables you to capture those changes and immediately see that on your report. But sometimes you don't want it. Sometimes you want that refresh only happens after you have completed all of, let's say, your ETL process, because in your ETL process, you get your date table first loaded, your timetables, your product tables, your dimensions first, then your fact table. And if you see the report in the middle of that ETL process, the numbers might be off, right? If your ETL process runs in the middle of the midnight and no one is looking at the report at that time, it might be okay. But if it is like in the middle of your ETL process, someone go and look at the numbers and numbers are like totally different because it is in the middle of the process, you may want to turn it off and then schedule the refresh or run the refresh through a pipeline as soon as, let's say, for example, your data flow refresh finished. That is one thing. Another thing, which is more related to the question we got from Dylan, I think, is another thing called fallback. So fallback, what is it? Fallback is a specific thing that happens when something we want is not going to happen in a direct lake mode, so it falls back to a direct query. For example, let's say if we are using a feature which is not supported with a direct lake. For example, SQL views are not supported. The tables are supported, but SQL views are not. Like if I create a SQL view and then bring that into my model, semantic model, and then use that in my report, that would be a direct query. It will not be direct lake. Or if the limit of my capacity reaches, right? And that is exactly what the question I think was about. So there is a limit in the capacity based on the capacity levels you got, how these are performing. Now, this limit, when it reaches the fallback happens, and fallback will make it a direct query connection. Direct query connection will make it slow, so the performance goes down. Now you have the option to turn that off if you want, the direct query option, but then you need to make sure that you have enough capacity to cover for that. So these are what they call as guardrails. These are, let's say, the recommended resource utilization in any of these capacities. For example, for something like F64, which is equivalent to P1, this is like the number of rows per table. Like you can have 1.5 billion rows per table. If you are loading more than that, it is probably needing more capacity, or it might fall back into a direct query. But all of these are kind of like some generic advice. You have to still monitor the actual value yourself. There are ways that you can monitor it. There are like those DMVs, dynamic management views in the Lakehouse or warehouse. They are a good thing to compare different query runs and see how fast they are performing and things like that. They can be good, helpful option. The direct query option or fallback option can be disabled if you want, and that can be done using a like Timdal or any of those languages, and it can be something like that you would say only direct lake is possible. If only direct lake is possible and then fallback to direct query happens, then you would receive an error, right? So you have to be careful enabling that. If you are enabling that, you have to make sure that you have the right capacity based on that capacity matrix to cover for that kind of scenario, so that the direct lake, so the fallback to direct query wouldn't happen. So that is fallback, and those are the, let's say, guardrails. All of these informations are available in Microsoft documentation platform. But the short thing is that direct lake is not exactly similar to import data. It's not exactly similar to direct query. It has features that would make it similar to import data and make it similar to direct query, but still it is not exactly like that. With the import data, you don't have that option that fallback happens, but with direct lake you do, right? With the direct query, you have always the performance challenge. With the direct lake, you don't have that performance challenge if you are not using a specific, let's say, type of SQL views, or if you are not hitting any of these limitations. So it's a good thing. It's a great new feature added. I would highly recommend using it. But when you are using it, just be careful the way that it has been used, the way that you have your DAX measures written. Sometimes some of those DAX measures might be translated into some kind of queries that would cause fallback. So things like that. So like some of the DAX measures might require creating like temporary tables within the measure itself using the virtual tables and things like that. And if those tables require bigger size of what your capacity limit allows, then it might be a problem. But these are not small limits. These are big limits. But when it comes to the measure, you are running the measure per user, so things might then become differently, and you might hit these limitations at some point. So a lot of things to consider. Any questions now?
Yeah, so one earlier was from Bhagwan. He just wanted confirmation that we have three ways to store data in Fabric, meaning direct lake, one lake, and data warehouse.
Not really. Okay, I'll explain it. So direct lake is what I explained just right now. This is a type of connection that Power BI would have to the Parquet files that is created when you create a warehouse or lakehouse. One lake is the storage layer across the entire Fabric environment. One lake is not a type of connection. It's the layer of storage. It is a logical layer of storage. The data underneath that is in ADLS Gen 2. And then what was the third one?
Data warehouse.
Data warehouse.
And in fairness to Bhagwan, he posed this question prior to your explanation of direct
Right,
link.
yes.
Just,
Yeah,
yes.
and data warehouse and lakehouse, they both are objects, like a database where we can store the data in it. They are logical objects. The actual storage, the data goes into one lake, under one lake, it goes to ADLS Gen 2. But the lakehouse and warehouse, they would give you a similar database experience where you can use that SQL Analytics endpoint and treat them like a normal SQL database using tools such as SQL Server Management Studio, but they also come with the Power BI semantic model on top of it as well, with the direct lake connection. So all of those features are as part of the lakehouse and warehouse experience.
Great, thank you. Those are the questions that have been posted so far. There's one other from Gonzalo that I don't know exactly how to. I'm not sure if it was a comment or a question, and he can bring that up at the end.
Okay, that sounds good. So that was pretty much everything I wanted to talk about. Still, there are a lot of details in every one of these aspects I mentioned. I have created, I think, more than 40 different videos on different aspects of Fabric. You can go to RADACAD YouTube channel and see most of these. These are the links. And the thing is that I would suggest you to go ahead and start it. If you don't have a Fabric capacity, it is quite cheap to spin up something like a F2. Because even with F2, which is like the minimum capacity, which would cost you basically $1 in every 3 hours, you would still quite be able to use these objects, and you don't have to be on F64 to use it. You can try it with F2 and see how it is working, how the direct lake features of it working. Some of the functionalities is F64 and higher, like Power BI sharing with the free users or Copilot. But for experiences that I showed you today, you can use it even F2. Feel free to reach out to me if you have any questions in the future, and that's pretty much it. So let me cancel this.